on 25th October, we have done our field trip for our course Carbonate and Sedimentology in Ketlotong Cave and Tambun. So the title for our assignment is Karst morphology in Kinta Valley. So let's find out. Hello guys, my name is Mama Azri and I am second year first sem.
Hello, my name is Muhammad and I'm final year student.
So hi everyone, my name is Nur Alana Binti Alias. I'm from second year first semester.
My name is Shafika Binti Syahir and I'm from second year first semester.
The Kinta Valley is a triangular-shaped, low-lying valley in the western belt of peninsular Malaysia, bounded by two prominent granitic ranges, which is the main range in the east that rises to about 1,464 meters above the main sea level. Glading Range in the west, which rises to about 752 meters. The valley widens from about 7 km in the north to 20 km in the south over a distance of about 45 km. The surface area of the valley is estimated at about 450 square kilometers. From the north to the south, the first tower karst observed in the area is Gunung Kontan. And lastly is Gunung Tempurung. The alluvial plain is located from 40 meters to 80 meters above mean sea level. The karst in the study area was formed from Kinta limestone of the Silurian to the lower Permian age. The hills are made of pure crystalline limestone. Farther away from the granite, the subsurface limestone at the south of the study area is less recrystallized and contains Paleozoic fossils. Other common rocks include several relatively thin argillaceous beds, which exceeds 3,000 meters in stratigraphic thickness. These were folded and recrystallized by regional metamorphism in the late Triassic. Karst is a topography formed from the dissolution of soluble rocks such as limestone, dolomite, and gypsum. It is characterized by underground drainage system with sinkholes and caves. How karst forms? Some rocks such as limestone can be dissolved by weakly acidic water. As rain falls through the atmosphere, it picks up carbon dioxide. When this rain reaches the ground and passes through the soil, it picks up more carbon dioxide and forms a weak solution of carbonic acid. As the acidified rainwater trickles down through cracks in the limestone, it begins to dissolve the rock. Water containing carbonic acid can slowly dissolve limestone, especially along fractures. As fractures enlarge, they can become caves.
Cave can be very large at underground surface. Collapse of cave roof causes of sinkholes.
Natural filling of sinkholes develops gently rolling sinkhole plains. Dissolving large amounts of limestone leaves behind the remnant of towers.
Most sinkholes in carbonate karst rock are formed via the dissolution processes with acidic waters, which occurs when rainwater absorbs carbon dioxide from the air and decomposing organic materials in the soil. It becomes more acidic and penetrates into the cracks, which dissolve the rocks. Other morphology of karst is wong. Areas that are located in the intersection of several fracture systems will always dissolve faster and develop into wong or closed depression. Wongs are always filled with tin-rich aluminium, and where they were formerly mined, ex-mining ponds were left behind. A wong in Ketlotong Cave has been developed into recreational park. The presence of number of belts on the cave indicate that these could have originated as the result of corrosive by condensation from a warmer allogenic water source flowing through the cave. The subsurface landform has evolved into pinnacles acting as pockets entrapping the tin-rich placer. Speleothems are commonly known as cave formations, are secondary mineral deposits formed in a cave. Speletomes typically form in limestone or dolomite solutional caves. Speletomes take various forms depending on whether the water drips, seeps, condenses, flows, or ponds. Many speletomes are named for their resemblance to man-made or natural objects. One of speletome types is dripstone. Dripstone is calcium carbonate in the form of stalactites, which are pointed pendants hanging from the cave ceiling from which they grow, or stalagmites, which are the grown-up counterparts of stalactites, often blunt mounds.
In the lost world of Tambun, an exquisite water theme park about 15 kilometers to the east of Ipoh, there is a unique feature named the Needle of Tambun. The lost world of Tambun occupies a site that was historically used for tin mining and is surrounded by as yet undocumented but relatively pristine karst landscapes. The first morphology of karst is tower karst. Tower karst are tall rock structures made up of soluble rock. Tower karst forms as near vertical joints and fractures are eroded downward by solution, leaving parts of a previously coherent rock mass isolated from each other. This variety of karst landscape occurs mainly in tropical areas. Thick limestones are divided into blocks by a grid of joints and fractures. Solution produce deep rugged gorge along the joints and fractures, dividing the mass of limestone into isolated blocks. Because the water dissolving the gorge drains to the subsurface, the gorges are not integrated into a valley system. In others, the deepening gorge reach a base level and begin to widen. Sufficient widening may create a lower level plain from which the remnants of the limestone blocks stand out as isolated, near vertical towers. The cones and towers themselves are sculptured by solution, so that the rock surface is covered by jagged panicles and often punctuated by pits and crevices. Second morphology is doorline. A doorline, also known as sinkholes, is a natural enclosed depression found in karst landscapes. Doorlines are the most common landform in karst areas. They are described as small to medium-sized closed depressions, ranging from meters to tens of meters in both diameter and depth. Once created, doorlines function as funnels, allowing the direct transmission of surface water into the underlying karstic bedrock aquifer. They may occur as isolated features or in clusters, causing a pock-marked land surface. Doorlines are formed by two main methods: the slow solution removal of rock from the surface downward, or by the collapse of overlying rock or overlying material into an underground cave or chamber. Solution doorlines form in such places such as joint intersections. Surface runoff will focus at these areas of weakness, leading to the solution of the bedrock. Water and solutes will then move downwards through the bedrock openings. The result is a funnel-shaped depression on the surface. Solution doorlines are considered to be formed by a gradual process of sagging or settling of the overlying deposits into the hollow left by an area of dissolving rock.
In conclusion, Kinta Valley is a progression of topographical forms which started 400 million years or considerably prior. The geographical history of the Kinta Valley is made up of two sections, which are affidavit and auxiliary disfigurement. Testimony started with the statement of sandstone exchanging with mudstone and in the long run framed the interbedded shake unit during Devonian. Kinta Valley karst shows advanced stage tropical karst maturity with a low surface to subsurface area ratio. This is due to the rapid degradation caused by wet condition in the fluvial and floodplain environment, which continues to exhaust the surface karst and leave behind a charged panicled subsurface platform under alluvial cover. The ratio of surface to subsurface karst shows that most of the surface karst in the study area has been extensively degraded. The local setting of the area includes a pluvial environment with constant allogeneic water supplied by rivers that flow from the granitic highland. Degradation is further fastened by the rock collapsing in blocks. The advanced stage of karstification in Kinta Valley could on the surface possibly represent almost the end of the karstification process, with continuous dissolution of the subsurface ongoing from the tertiary to the present.